So I would like to welcome Deep, everyone. Thank you so much, Deep, for joining today. Deep, do you want to give a quick introduction about yourself, and then we can get started with the workshop?
Yeah, that works.
Yeah.
Hey everyone, I'm Deep. I'm a senior data engineer here at Robinhood right now. We are based out of Menlo Park in the Bay Area. That's our headquarters. Everybody might know about Robinhood at this point. We are a fintech company that allows people to trade shares, crypto. We are also now a bank officially, and that's what I'm working on. Before Robinhood, I was at Meta, used to be called Facebook back then, and I used to work on their ads infrastructure as a data engineer. And before that, I was at a bunch of small startups where I learned how to build like products from end to end, like zero to one. And I don't know if you guys saw me. I was here. I was at UC Davis, I think a few weeks ago, for the fireside chat that Sambhav and team had managed to, bring up. And I feel like I've seen some of you there, but I'm excited to get started. Sambhav?
All
Yeah.
right.
Sorry.
Oh, yeah,
Yeah.
no worries.
Sorry. What were you saying, Deep? My bad. What were you saying?
No, nothing. No worries.
Oh, okay.
I'm
Yeah. No,
ready to
please,
start
please.
here. I can get
Yeah.
started.
Please go ahead. Start. Everyone's ready? Yeah. You can go ahead and get started.
All right.
Yeah.
Cool.
And Yash is gonna be here. He's behind the laptop, so you might not see him. But I'm gonna head out, and Yash will be taking care of the workshop.
Hmm?
Cool. Before we start, Yash, is it gonna be 1 hour?
Yes,
Okay,
yes. We have an
perfect.
hour-long slot here.
All right, perfect. We have full hour. That's great. All right. So today we are gonna do a working workshop on how to build a data warehouse with PySpark, right? And I want to make sure there's a few things that you take out of this whole workshop. It's not how to code because you don't need to code anymore. You can just ask AI and it will do it for you. It's why you need this, right? And these concepts are now becoming much more important because otherwise you're replaceable by AI. If you don't know why you're doing something or why you need to start becoming a thought leader in the space and like start to preach why you need some things. Otherwise, you'll start slowly be replaced by AI to just write code, right? So one thing I want you to take out of this whole workshop is why we need data engineering, what data engineering really means. Because even if you don't become a data engineer in the future, there are software engineers that I work with, there are network engineers, there are people who I work with who don't understand what we do, and that creates kind of a friction. They are not able to utilize data engineers power or data engineers skills to the maximum, and they feel like, oh, I'm stuck, what should I do, right? So at least by the end of this 1 hour you'll be aware like what data engineers can do. If you're going down that path, great, you'll learn something very technical and core to your own field. But if you're not going down that route, if you become a data scientist or a network engineer or a hardware engineer or even like a back and front end software engineer, you will know how to interact with data engineers because you know what they do, right? Cool. All right, so why does this matter, right? Let's think backwards. Um, you've all seen dashboards and analytics, right? Where a CEO comes to you and asks, how much money did we make last year, or this month, or today, right? And there are dashboards every company builds. That's not what we do, right? Mostly data analysts or some companies call it BIE, business intelligence engineer, or these are the people who will build these dashboards, but not only build, they are the one who extract insights out of these dashboards. Reading a dashboard is also a skill which that field of endeavor has, right? Like data analysts know how to read a chart and then how to extract insights from it and how to answer questions. And once they answer these questions, business is suddenly, data driven, and then they know what to do. They have insights. Oh, we are losing the users at this point of the graph, how to increase revenue, etc., etc. But how do we actually collect all this data that shows up here, right? That's what a data engineer do. We are actually plumbers. And if you see LinkedIn, a lot of data engineers are writing in their bio that we are data plumbers, And that's what we do. We are doing the plumbing from the service side all the way to the analytics side, the plumbing of how the data will flow and what the data will look like at every stage. That's what we are doing, right? Now, imagine going from orders on Amazon, right? The order you're placing right now to the CEO asking how much orders were placed last year. Imagine if this problem comes to you. Now, the Amazon orders are saved when you place an order. They're obviously saved in a database called transactional database, right? These are Postgres, MySQLs. These are your transactional database that are really fast to write. They're really fast to read only when they are super, super normalized. And that's why all these databases are very, very normalized, right? And by normalized, I mean they're literally broken down into a snowflake schema where each table only does one thing. If you start making these tables really flat and long, your read will be really, really slow and your app performance is really slow. That's one thing you cannot ever degrade, right? Your app performance. Your app needs to run fast. And that's what you cannot degrade. That's why your reads need to be really fast and your writes need to be really fast. And that's why you use transactional database. And and when you work with transactional database, they are called OLTP, right? OLTP is this term that lives on the transactional side. And the database design there looks completely different. Do data engineers have influence on designing that? Little, not a lot, just a little. Mainly, these big companies have database architects and software engineers who specialize in these databases, right? Only the OLTP or the transactional piece. This transactional piece is Postgres and all that. Can we run analytics on it? We can't, because if you start running analytics queries and you start querying like how much revenue did I get yesterday, right? From all the products that I sold, how much revenue did I get? If yours is a smaller company and you have like 100 to 1,000 rows, that analytics works just fine. That query will run on the Postgres database just fine. But as you start doing more and more analytics, let's say there are 100 analytics people like data analysts now, right? And they're all querying this Postgres database at the same time. What will happen? The Postgres database will be busy serving these queries and they will never be able to serve the app, right? Because the app is also making the request, the analyst are also making the request. What's happening is this database becomes overwhelmed and you cannot run analytics. And that's not the only reason. The other reason is these databases are not optimized to run aggregates, right? The data cannot be aggregated fast. There are a certain SQL optimization or SQL engine optimizations that are missing from these databases. And that's why you need to move all that data over to something called an OLAP. And that's where the analytical piece lives, right? So you must have heard of databases like Redshift, BigQuery, Spark, Databricks. Like Databricks is a whole company, but they do have their own internal databases that you can use. Snowflake is one, right? These are all companies, but what they do underlying is they help you build a data warehouse. And that's what we are trying to learn today, right? A data warehouse and a database from Postgres. How do we get there, right? Now imagine you can always say that I'm going to export all my databases from Postgres into CSVs, for example. And again, that works, right? That works for a low level, small startup where the data volume is too low. But the raw data itself that we are talking about is chaotic. There's so much happening on the app layer that all that data is not easily readable or consumable by analytics. And if you had to build analytics on top of that, and trust me, every single one of you, as soon as you go into a company, even like people working in finance, I work with them as a data engineer, and now they've started to understand these concepts. They have to use words like data lake versus Postgres. And like I said, whatever field you're from, this will be useful for you to understand what a data lake is or a data warehouse, right? There's a subtle difference between a data lake and a data warehouse, and we'll get to that in a second. But like now, all these orders that were happening on the app are migrating to your OLAP database, right? There are multiple ways to do this. One of them is called ingestion. What you're doing is you're copying all the data from the Postgres tables and you're copying them to your analytical or OLAP databases, right? Via files. They could be like CSV, they could be anything, but your OLAP database needs to know how to run it. And all that process from, extraction of data from Postgres, transforming it to make it dashboard readable, and then loading it into a dashboard is called ETL. I'm sure everybody's heard of ETL. That's what it means. It means extract, transform, and load the data, right? Now, imagine if your company goes to 10 terabytes of data. You need obviously compression because storage is not cheap. That's what it gives you. And then you want query latency that's really fast. What do? Right? You want your analytics to run really fast. You don't want your dashboards to load like after 10 minutes. You want to answer questions really fast. Like I said, every dashboard you see ever in the company runs on a data warehouse. College projects that you build sometimes are on CSV files or like Postgres databases, but not everybody needs an OLAP database because only companies would really need that, right? So that's why we are here to learn that. Right. So this is what I was talking about. Like there are users making all these transactions. There is data about this user, whether this user is Prime or not, right? On Amazon. What kind of things does he like? What should I show them as a product, right? So these all transactions are coming in into the OLTP database. We run these ETLs to bring them into OLAP, but that's not where our job ends. That's actually just the start. We bring all this data in OLAP, and then we want to make it highly readable, very consumable, and we present it to data analysts or data scientists or software engineers, leaders in a very readable format. And again, we have a new ETL here, and that shows up in your charts, right? And again, we are going to move to a working workshop where we'll all code together pretty soon. But I want to make sure everybody understands what we are doing and why, right? Because again, like I said, this will be useful once you go in the industry. Now, what is a data lake, right? A data lake is where you go and dump your data. It's literally a place to dump all the data. It is not structured and it's not readable at this point. So when you bring data from OLTP to OLAP, you're basically just dumping your raw data as is. You're not doing any transformations. You're just dumping your data into OLAP. When you start making sense out of that data, you bring it from a data lake, you build certain structure that makes the data very useful. And we are going to learn that structure today, later in the talk. But when you make that data structured and easily readable, and that's when it becomes a data warehouse, right? A data warehouse is much more structured than a data lake, and you can write queries because the data is structured in the right way. There's also a term thrown around called data mart, right? So data lake, data warehouse, and then there's this third thing called data mart. Data marts are, don't worry about them right now, but just really quickly, they are on a small section in the entire data warehouse. So a lot of data marts make up a data warehouse. A data mart is specific to a business use case. For example, in Amazon, it could be just transactions, right? There could be another data mart called recommendations, for example, or like prime users. Like all of these small data sets together, they make up a data warehouse. Cool. We don't need to go a lot detail into this. It's just a difference on like what data lake versus data warehouse. Um, then here's what I was saying. So we ingest files from Postgres into our OLAP database, right? Then we transform it. And transformation means we clean it. Like there must be duplicates somewhere. There must be, not just duplicates, but like erroneous data. We are exactly cleaning the entire data set so that it makes things readable on the OLAP or on our analytics side, right? And then we model the data. Modeling and data modeling, this is where it comes from. When we say you're data modeling, what you're doing is you're structuring the data in a way that it's easily readable. And you want to make the data easily readable because as as a data engineer or as a front end or back end, as any engineer, right? What you want to do is you want to make your data models really robust because the end user is there obviously is a person or AI or whatever who's trying to use your data. And if your data is not modeled or structured in the right way, you see where I'm going with this. Like they'll face a lot of trouble and you're not able to extract insights out of the data that you created, right? And then in the end is the serve part is where you take all the data and you're serving it in BI tools, or this could be the serving layer could be anything, right? For simplicity, it's just a dashboard, but it could be a machine learning model, for example, that wants to read your data. Or in some cases, we even send the data back to Postgres, to the service, right? That's rare, but when that happens, that's when you're actually becoming successful in your career if you're a data engineer, right? You want to create insights and you want to create data that flows back into the system. For example, on Robinhood side, right? When you're running the bank, when you're enrolling for a bank, you have a tier that you join in. The higher the tier, the better. I worked on an ETL that looks at all the users' profile and their money that they have and everything, all the smallest features, and it computes the tier for you. And that tiering logic flows back into the service in the app. And when a user applies for the banking, they get enrolled into one of these tiers. And all that tiering logic is pretty complex. It cannot live on the app side, right? Because the app, you want to keep it simple so that the app is really fast to use. The tiering logic has to live in analytics. And then you bring the data back in a consumable way back to from analytics back to the app, and then you use it. So that's a real life example. Cool. Let's begin some code. That said, all right. So what we should do is I've made this really simple for you. Um, you don't need to set up anything. We have Google Colab. It's a notebook experience that Google has, enabled everybody to use. It's free to use, completely free. I see everybody has their laptops open. If you're interested in coding in Spark and learning how to model the data, and this will be useful in any project that you do. Um, so let's try to access this URL for a second. It's just I made it into a tiny URL, but it's tinyurl.com mini warehouse workshop. Where it will take you is my GitHub link, right? It should look something like this. It takes you to a GitHub link. And again, I don't know if everybody has their GitHub set up, but if not, I highly recommend. It should just probably take a minute. Some show of hands if people are able to see the GitHub page. Oh, thanks. Since I'm, doing this virtually, it will really help. I'll keep asking questions if, to just get feedback from the audience. I want to know if everybody's engaged and running with me. If I'm going too fast or slow, I need to know that. Thank you so much.
How are we feeling? Are you guys up to speed with Deep? All right. I think we're good, Deep.
Great. All right. So the second step that I want you guys to do is go to Google Colab. Just type Google Colab, right, on your browsers and click on it. Right. So
Sorry, y'all. Wait, hold on. Do something.
To sign into Google Colab, you'll probably need to sign into Google Colab with your Gmails.
Start versus Zoom. Wait, Coin Doc, maybe. Yeah, Zoom. There, it's a sharing the whole thing. No, it's only showing half. Change. Yeah. Where is this window? Yeah. Set up. Okay, there. So. Hey, Krishna called me to us. Take it outside. Krishna. Come down. Yeah.
All right, have folks signed into Google Colab?
How are you guys feeling? Are we in Google Colab? Who's having trouble doing this? Sorry, which one? Yeah, Deep, can you go back to the original, I think, repo you had up?
Yeah, of course. It's
Is it
tiny
this one?
URL mini warehouse workshop, and then that will lead you, if you type this, it will lead you to this repo. Or I can, if it helps, I can send you this link as well. I don't know how. Probably paste it in the chat here.
That can work.
The thing is, it's a pretty long URL. So that's why I made it into a tiny URL.
Okay, I'm gonna have this URL up, and if you guys still need to navigate to the collab, yeah. Otherwise, I think we're good.
All right. So as you enter, so what I want you to do is copy this GitHub URL.
Discord. So people can access it.
So copy this GitHub URL that I have
They can
given
access
to
the
you for
coins.
this
Okay, yeah, we can do.
notebook, right? Once you've copied this URL, you can just import it easily. So you can say in your Google Colab, there's an option to fetch something from GitHub, right? And it says enter a GitHub URL. That's where you'll paste it. Not the tiny URL, but the actual GitHub URL. This is the only piece I feel like might be slightly complex because this is a setup. After this is once you have the notebook set up, it's pretty smooth sailing. And don't worry if you don't have things set up. You'll be still be able to follow the code because I'm going to run it on this big screen that you're looking at one by one, and you'll be able to see the output. And I'll keep explaining as I go. So it's not necessary to run this notebook at this point. If you can, great, because you'll be able to navigate the whole notebook experience. And in my experience, like all great engineers, whatever they do, even in front end or back end, they are getting used to the notebook experience to do some kind of rough analytics. And I say this because everybody will need to run some kind of analytics in their work. Even if they're not in the analytics field, they'll have to do some kind of analytics. For example, if you're working on front end, you want to know why a user is always dropping off in when they come when they're signing up for a new product. Why do they always drop off on this page? For example, when they have to add the address, they drop off on that page. You want to know that analytics of the user flow, and it's called the user funnel, because user goes from, like, you have 100 users who try to sign up, then you have 20 who finally manage to sign up. Where did the remaining 80 go on the funnel, right? Where did they drop off? And once you know that, hey, 65 of those 80 dropped off on that page where I was asking for their address. you would suddenly know that maybe that's where the friction is. So everybody needs to run analytics, and this notebook experience will just help you how, right? So that said, like it's okay if you don't have it, but if you do, that'll be great. So all right, so we are pasting that URL, the GitHub URL here, right? And once you do that, if it's successful, you'll see this notebook pop up, and all you do is just click on this button and it will open up that notebook for you. I'll wait a minute here to if you guys can open that notebook up. How are we doing on time? Oh, we have 30 more minutes. I think this should be a breeze. All right. So at the end of this whole notebook, what we are going to do is we are going to go from really raw data that is now in CSV, just to make it easy, of users, their user fields, their products that they're buying, the product categories, the orders that they place, and the order items. Really messy data. What we are going to do at the end is bring it to really easy analytics, saying what was the total revenue by product category, right? That was the question that was asked to you by your CEO. Like, break it down by year. I want to see which product category is generating how much revenue. This is the chart you want to come up with in the end. And we'll slowly go by cleaning the data. We'll extract data, we'll clean it, we'll transform it the way we want. And then at the end, we'll have not just this chart, but you'll have a really flat database, a really flat table that can run not just one analytics, but every single answer. Every single question that you ask, it will be able to answer that. That's what you'll have by the end of this notebook. Yash, can you poll the audience to see like if anybody's having trouble bringing up this notebook?
All right. Does everybody have the notebook in front of them? If you guys did need it on Discord in the announcements channel, I did also post the link to the GitHub. All right, I think they're all good. Deep.
All right, cool. So here's what we do. Actually, I forgot to talk about Spark. That's one of the most important pieces here, and like I think it will be interesting to everybody. Unfortunately, I did not have it in my slide. So what I'm gonna do is a very easy thing. I know everybody can do this, but here's I'm hoping to see a good image. All right, this looks good right here. Cool. So imagine this. You're running analytics on your computer, right? You're working with maybe 5 gigabytes of data. That's fine. 10 GB is also fine. Maybe 100 GB is also fine to run on your computer. But anything beyond that, a real life scenario, you're working with terabytes of data, and some of the pipelines I built were petabyte scale, right? Can one computer run this? Absolutely not. Like I don't think there's any computer who can process data this fast, because if you can argue I'll get like, I don't know, a thousand hard drives, right? Hard disks. But those are still really slow in read and write. You want something that's fast. So you load all the data up in memory, right? But there's no RAM build that can hold a terabyte scale or petabyte scale, right? So what Spark does for you, and Spark is very powerful. I'll give you a few examples. Spark came out of a literally a university project in 2011, I think. Might be wrong of the timeline there, but it literally came out of a university paper, and then it took over the world. Every single company wanted to move to Spark, and they did, and it's still useful, right? Even after like 15 years, Spark is still relevant in an industry that moves really fast, and the products are churning so fast. Spark remained. Not only it remained, there is a whole company, I think a $500 billion company called Databricks, right? The Databricks founder was a student of that university. He is the one who wrote that white paper. He came up with Spark. He open sourced it, which means he let everybody use it for free. Until he came up with his own company, Databricks. He said, not everybody knows how to install Spark in their own machines and their infrastructure. Let me create a company around that. So he came up with Databricks. Now it's like $500 billion worth of company, right? And it's doing end-to-end analytics. That's what Databricks does. Databricks is the wrapper around Spark. So if you're using Snowflake, if you're using Databricks, or if you have Spark installed natively on your computer, or you have Spark installed on your infrastructure as a company, everybody's using Spark. What it does is it takes all these raw data that we were talking about and it distributes it into different machines and it gives each machine a small task. For example, it could send all the names starting with A, and it's the very simplified version of this example. It could, there is a cluster manager who's kind of the master, it's the boss, right? It's telling all these smaller machines on what you should do. And all these small machines that we have, and obviously in this era of cloud, the smaller machines are very accessible. You just go to AWS, you get EC2s, right? You give each machine a really small task, and they will only process all the orders that begin with the digit 1, for example. Or this machine will only process orders from names with people like that started with the letter A, for example, right? So each of them are doing like really small work. For example, a 100 gigabyte data set can be just, split into 5 machines of 20 GB each, right? And then once they're all done with their processing, they all write out to the data lake individually, right? And the cluster manager is keeping tab of who's finished, who's not. Once everybody has written data out in that structured format, you're good. So now this is super scalable. If this increases to 1,000 instead of five, I'll have 50 machines, right? Or I'll just have 5 machines with bigger RAM. But what Spark is doing is it's loading all the data into memory, and then in memory is really fast and it processes that and spits it out into the data lake. That's what Spark does. And today, what we are going to do is we are going to build this entire warehouse going from raw data in CSV to really structured data in warehouse using Spark. Now, you can install Spark on your local machines, but if you do that, you're not getting the distributed data concepts because your data is not getting distributed. It's literally running on one RAM on one server, which is your computer, and you're not gaining any benefits out of it. Google Colab, however, is letting you borrow their machines, and depending on what the workload is, they will assign machines to you. For the purpose of our workshop today, I'm pretty sure this is really low scale and it's using like maybe like less than a GB of data. So it will probably assign just one machine to you. But as you scale up and you have some pretty good analysis to do, you will require more machines and they'll allocate it for you. You don't have to worry about the machine part right now. Cool. So what we are doing is we are initiating Spark here. And Spark, when it came out, used to be written in Scala and Java. And when you write Spark with Scala and Java, it gets really complex, right? So later on, they came up with PySpark, which is you can write it in Python, and it became slightly easier. And now the industry, most people are just using PySpark. So if you run the first part of our notebook, it's initiating the and don't worry if you get an alert saying you didn't author it, you can just run anyway. So when you run the first one, and to run, you basically you just click on this or you press Command Return on your MacBooks. If you have a Windows machine, I don't know, but it must be something similar. Will probably take a minute to. Cool. Took 23 seconds. What we did here is we initialized it, right? We initialized just like Spark session. And we're saying that for this Spark session, we are calling the app name as mini warehouse workshop, right? And we're creating this instance of Spark that we'll use everywhere. And this Spark instance is very important because it's the main class, and that's how you interact with Spark, right? That's how it knows how to submit that job to the Spark cluster. Cool.
Is the one you
Um,
is
sorry.
your or does
Yash, are you saying something?
No. Sorry, continue.
Okay, cool. After that, we want to just run this just to make sure we are starting with a clean directory. And you will need to do this because uh, because we need these CSV files, right? So I want you all to go here, tools. Sorry, where is the terminal? It used to be a terminal somewhere. Give me 1 second. How do you start the terminal from here? Oh, right here. Sorry. On your bottom left, there is terminal that you get access to. And depending on like how technical you are, I'm assuming since you're in this talk, you might be. What I need you to do is type ghauth login because you will need to log into GitHub to pull the CSV files, right? And this is a very convenient way. You could go to the UI and log in into GitHub, but you can also do this from here. So ghauth login and like where do you want to use github.com, SSH or HTTPS, HTTP, you can just do HTTP. And then do you authenticate? Yes, right? Just press Y and then log in with a web browser. And then press enter. Okay, in some cases it will say it could not open a new browser for you, and that's okay. You just copy this URL, or you can directly go to github.com login device, which is what I'm doing here. So it's github.com login device, right? And then it will prompt you. In some cases, if you haven't logged into GitHub, it will prompt you to log in. So please do that. And then go to github.com login device and then continue, right? And this code was what we had here. It gave you a code here. So you paste that code here, press continue, and then continue and authorize GitHub. Cool. Give me 1 second. Because my GitHub is linked to Robinhood, the company, they will not let me, but I have a way. Just give me 1 second. Oh, that should work. Okay, yeah, cool. Let me know, folks, if you're facing trouble with this. Are you able to log into GitHub?
How are we feeling, guys? Into GitHub.
Nice.
All
All
right.
right, cool.
Looking
So,
good.
cool. I'm logged in, right? So now we can start running these commands. And trust me, like it becomes much easier. So what you're doing is you're just cleaning up and then you're saying git clone and you're cloning my directory, right? That's where the data is. So the base path is mini workshop data, and then there are a few CSV files that we would need. So once you have done cloning, I just want to make sure I have all the data. So I'm running ls and it will show you on ls data, it will show you these files. Cool. So let's read these files into Spark. And we only have 15 minutes left, so I want to make sure we run through this pretty fast. And now we are just running these commands. But you're reading these files, right? So spark.read.csv, and you're reading user CSV, user fields, and all of these 6 CSVs. And I'm just going to run this. Cool. Ran in 8 seconds. And now we will see what they look like, right? So let's look what the user's data looks like. It contains user ID, username, city, country, field, and created at. and all the names of these, astrophysicist scientists, where they used to live, what country they were in, their field ID. We don't know that for sure, but let's look at the field, user fields, right? And we will understand what user fields really are. I don't know at this point, but like if you print the schema and then you say user fields dot show, it will show you. So the user fields are the field of what they were from. So astrophysics or particle physics, for example, like I don't know if I have Marie Curie in here, but Marie Curie was obviously in particle physics. There are people in planetary science. These are the fields that they used to work in. Cool. Now, these people, these scientists are placing orders, right? For their lab equipment, for their experiments. I don't know what they're doing, but um, they're calling all these products, right? So they're, I think it says truncate false. Okay. I know it works with display, but never mind. I think it should be fine. All right, so we're looking at these products. That's what they're ordering, right? Like gravitational wave detector, that would be Kip Thorne, etc., etc. And then each of these products are in their own product category. The product category could be instrumentation, optics, etc. So this is how the OLTP or the Postgres database looks like. It's super normalized, right? You will see that products and product categories live in different tables. The reason is because they don't want to duplicate the data. And every time in the orders table, for example, they only want to save the order ID, the user ID on order date. And then in the order items, they want to store the order ID, the product ID, and the quantity. You see how all these tables are doing just one small thing? You cannot run analytics on these tables anymore because they're not joined, and you'll need to perform a lot of different joins for you to be able to answer the question, how much revenue did your company do, right? Okay, let's look at the goal. The goal is you want to calculate revenue per field, which was astrophysics. The fields were astrophysics, particle physics, and planetary science. You want to know by actually we are doing it by by product category. Cool. So the goal is we want to calculate the revenue per product category. Uh, so here what will happen is, let's say you had to run this analytics on your OLTP. What I want to show you is, look at the query. You'll need to do literally a lot of joins, and you'll need to compute a lot of fields to do this in your OLTP. For now, the OLTP will work fine because the data is really, really small, right? So it will still end up running. But as this data blows up, you cannot make so many joins on your data because the OLTP or the Postgres database cannot handle it. So the OLAP way is the only right way to run analytics, right? So what we'll do is we'll do some cleaning first. And if you see here in the user's data, you might have noticed we do have duplicates, right? Like Neil deGrasse Tyson is showing up twice. Vera Rubin is showing up 3 times. So the data is obviously not clean. And this is a real life scenario. We do get duplicates all the time in our OLAP databases from OLTP. As you're doing the ingestion, we do get duplicates all the time. So the first step here is to clean the data, right? So what I'm doing is I'm using the created at that was in users, and I'm creating a date out of it. And I'm dropping duplicates out of user ID. Once this runs successfully, you'll see if I run the user's clean df, my duplicates are gone, right? I show up Neil deGrasse Tyson once and Vera Rubin only once. Cool. Even orders had the same problem. Orders had duplicates too. So let's go ahead and clean it. And if you see, we don't have them anymore. Now, something that you something that will be really useful for you to know is how do we do data modeling on the data warehouse side? Something called star schema. Going from 6 different tables of users, products, product categories, orders, etc., we go down to 4 tables that are really flat. And it looks something like this. Oops. Looks something like this, right? So the star schema that we're creating, what we're creating is really flat tables. So out of that, those users and users attributes like countries and everything, we'll create a table called dimensional customer. I don't know if people have heard about fact and dim tables, but this is the real world data modeling that I guess a professor called Kimball came up with. There's an amazing book that Kimball wrote, Data Warehousing Toolkit, that I recommend everybody should read. Uh, so Dr. Kimball, he came up with this whole idea and this whole concept of star schema and fact dim based dimensional modeling, where we take where we create a fact table. A fact table is everything that is quantifiable, right? So orders, number of orders, the quantity of the placed, everything that's quantifiable and tangible goes into one place called fact orders, and everything that describes this order, that is descriptive or kind of an adjective, right? Like, oh, which user placed this order, which product was it for, they all go in, which date it was for, they all go in dimensional modeling in dim tables. So our goal is to create a fact table that just contains IDs, like what's the order ID of this fact, what consumer ID, but we won't place what region or name of the customer it came from, right? Because that becomes redundant data. You can always use it as a foreign key and join it back to the dim customer, and suddenly you have all the information. Once you join the fact orders with the dim order, you will have what name or region it came from, right? So this is the basic silver layer that you're building. And this is the foundation data that you're creating as a data engineer. You're creating fact and dim tables. Cool. So that's what we'll do here. We'll create a dim user, which is everything I know about that user, right? I'll join it to user fields. As you guys remember, there were two different tables. One was user and one was user fields. We'll create a flat table that contains that user and the user fields all in one table, because we don't want to keep making recursive joins. We want to make a one flat big table, right? So we'll join it with user fields on field ID. Here we have it. We have user ID, username, field name, the country they're from, and we created our own surrogate key. We created our own key because we don't trust the keys that come from the OLTP databases. And there are multiple reasons why. I don't think the time is allowing us to go into why we need this key, but you can always look it up. Now we are going to create a dimensional table for product. Again, if you remember, we had product and product categories. We joined them together to build this flat table called dim product, right? And it contains all the knowledge I need about a product. And you can run analytics on this, right? You can be like, oh, I want to know how many products I sell that are above $1 million, for example. And it will return data back to you. We also create a dim date. This is, I think, not important at this point, but it just makes analytics really easy. You create a dimensional table for the dates themselves, like, oh, what, like the order date, and you extract like year, month, and dates out of them. So might not be important at this point. This is where the crux of the problem is. The fact sales. This is what we are creating. It's a really flat table that you create that contains everything. It contains order information, dimensional, users, product, dim date. It contains everything, right? But there's one thing you do here, which is analytical, that you cannot do on OLTP side, is you're computing a few transformations. Here we are multiplying the quantity and unit price, which is how many products you bought and what was the price of each product, into revenue. And that's what revenue is. Like if you're selling 10 products of $100 each, then you're making $1,000 of revenue, right? So let's run this and take a look. Here you have it, right? So now you have a really flat table. Remember how you had fragmented data all over and you had to make a lot of joins just to do it for one analytics? It will be different here. You will store this table, fact sales, as a table of its own, right? And every analytics that you do is now powered from this table. And you can slice the data however you want, right? So let's look at that same query that we ran earlier for field name and run it in analytics. It becomes really easy. And not just easy, it also is really fast. Like, trust me, like sometimes the queries on OLTP would take like an hour to run if you actually try it. But with Spark, it could run in few seconds. And that's the difference and power of Spark. Okay, so now that you have a flat table, let's denormalize it further for the BI layer, for business intelligence, right? We don't want the user to make all these joins every time, right? We don't want data scientists and analysts to come and make these joins with users, with date, with field name every single time. So what you do is you create another table and you materialize it. You create a table called analytics flat, for example, and then you make all these joins for them, and then you just store the data once. This also saves a lot of cost for the company because every time you make a new join, the company needs to run it on a compute machine, and that compute machine is costing money, right? But let's say if every morning I wake up and I make these joins and store it somewhere, so that if a CEO comes or an analyst comes or anybody comes and asks me a question, they have this table ready to use and they don't have to make the joins anymore because you did the joins for them. Now you're saving the company a lot of money because nobody has to do joins anymore and it's only once. Here we have it. We have a big flat table that contains everything you need to know about orders. You have the users' names, you have the category names, you have the country names, year that the order was placed in, the username, you have everything in one single table. Now, this one big flat table can run any analytics on it. For example, you want to do it by, we did it by field name earlier, you want to do it by category name. You just say, I want to group by category name and year, and it will just do it, right? You want to plot it. This is how you plot it by just using, I'm pretty sure you all use matplotlib. Um, Here, you can see it. But the same data set can power by anything, right? You want to country, you just change the group by to country, and it will show you the revenue by country. Like USA spent this much and UK spent this much. I know we are short of time, but we could have done two more exercises here. But I highly encourage you to, on your own notebook, try this out. Try these two questions out. You're trying to run real life analytics at this point. Like, which research field generated the most overall revenue? Try this out. Trust me, if you're able to successfully run this, you're ready to run analytics in any company. And it's not just data analysts who run analytics. Everybody needs to run some kind of analytics in their own fields. And this will be really, really helpful. And then the second question is, who are the top three scientists by total revenue? So I know I had to run through this really fast. We only have a couple minutes. Are there any questions from the audience? Like anything that you didn't feel comfortable with?
Is there anyone that found one part particularly difficult or particularly confusing? Okay. Okay.
Yeah, I wish I had more time. Maybe 2 hours. I could have gone into detail with every single topic, but it would also bore you to death if you're not into this. So, all right. I had a few more things to share, but I think I'll just share this slide deck offline and you can go into it if you're into it. Um, but I think that's it. That's my time. Thank you so much, guys.
Yeah. Thank you so much. Deep, would you guys be interested in coming up asking Deep questions one-on-one if you have any of them? We'll have him on for maybe another 10 minutes. All right, Deep, are you okay to stay on for another 10 minutes?
Yeah, of course.
Okay. Yeah, thank you all so much for coming. Really hope you guys learned something and got something out of this. And yeah, we have many more workshops coming up as well. So stay tuned. All right, thank you guys. Bye.
How's the prep for the hackathon going, Yash?
It's going pretty well. We have been yeah, pretty busy this morning, running around, but things are going pretty smoothly. We had check-in, opening ceremony, our first workshop going, and now we're just gonna coast through the afternoon with lunch and some more workshops as well. So yeah,
Nice. How many teams did you have?
not sure how many teams there are. We do have around 100 people checked in so far. So yeah, that is where we're at right now. I think our attendance for the opening ceremony was also around 100.
That's
So
awesome.
it
That's
was pretty
really cool.
good. Yeah, we're pretty happy with that outcome. Yeah. Excited to have you here with us tomorrow as well.
Yeah. I'm excited to begin the judging and looking at all these projects. But even before that, I think if anybody needs any help with their project, just guidance, mentorship, I'm
Yeah.
available. Like, just have them shoot an email or text to me.
Oh yeah,
I
for
can help
sure.
them out.
Yeah, we've published your LinkedIn on our Hacker Hub, so they definitely have access to that as well. So yeah, yeah. I did have a quick question about like your experience. Obviously there's a big learning curve with all these things. How did you go about learning it? Because I'm assuming you learned this before AI, right?
Exactly. Um, So here's the thing, like I was saying when I came up on stage last time, there is no school for data engineering. The
Yeah.
only school that I know right now is in San Francisco, and there's only 22 students who are learning it right now, and they're the first cohort. There is
Hmm.
no school for data engineering. There's a school for data science, there's a school for machine learning, there's a school for just back end software engineering, front end software engineering, but data
Yeah.
engineering is not taught in schools. So
Mhm.
I only learned on the job, right? I
On
actually
the
learned
job.
from the industry. I
Hmm.
was a software engineer earlier, and then suddenly data, amused me, and I started working towards data engineering.
Hmm.
And I started writing a lot of really complex Spark jobs. And one thing I also didn't mention is it's not as easy as it looks when I'm showing you on this notebook, because
Yeah.
when you're working with petabytes of scale, like petabytes of data, right? You
Hmm.
need to know how Spark works internally so that you can go and optimize Spark. The
Yeah.
main job that we run is not, take data from here, transform it, and load it somewhere. It's the complexity that we deal with when it comes to like petabyte scale, right?
Hmm.
You need to optimize Spark, and every job needs to optimize Spark in a different way.
Oh, so it's very just in depth and very particular
Yeah.
to every task that there is.
Right.
Yeah. How
And
did
I
you?
honestly, to answer your question, like I just learned from, like I said, reading a lot about it and then
I see.
practicing things. So I think
It,
you can't get away from that, like books
yeah,
and, curriculum and reading and practicing. I think that's the best
interesting.
way.
Yeah. How did you like obviously you're learning on the job. How did you manage like learning something new that takes this much, time and energy to go depth and also like still contributing to your work deliverables? How did you
Yeah, you
balance
just
those two?
gotta set realistic milestones
Hmm.
and just go about it, right? You're not gonna learn everything in one day, but if you
Yeah.
make a plan for yourself, and now with AI, learning is becoming really easier. You can just plug in to say, I want to learn this and show me a plan how. It will do the work for you. It will break it down into smaller pieces, smaller milestones. And
Hmm.
then every day you just target to learn that 5%. That 5%. You keep doing it, you stay consistent. I think there's no better way to
Yeah.
go about this. Like right now, the reason I was showing everything astrophysics related
Hmm.
was because I'm really into it, right? I've set realistic milestones for me. I'm really deep into the theory of astrophysics. I'm
Hmm.
learning equations. Like
Oh my God.
last month I was deriving, Einstein's the most famous equation, like E is equal to mc squared. I was deriving it with someone, right? Like just on YouTube, that guy was like, do this, do that, and I was actually deriving it. That's the only way I learned these things. I spent 1 hour every day consistently. I
That's
bought
true.
I bought my first telescope, I bought my second telescope. I'm
Uh,
imaging these things. I'm really deep into this now. So
yeah.
that's the only way, staying consistent.
Yeah, exactly. You just have to force it to be part of your routine as well.
Yeah.
So, yeah. That's good to know. It's pretty common in the workplace also, right? If you want to transition roles or ascend roles, you do have to do this where you set aside time outside your work. maybe
Yeah.
deliverables and hours to pick up skills.
Yeah. That's why I'm here, right?
Yeah, of course. Yeah, sounds good. Did you have a
Okay.
question? Did you have a question for him? Or just saying hi? Okay, okay, awesome.
Just saying hi. Cool.
Yeah.
Nice to meet you. Thank you so much, folks. I hope you got something out of this. I don't know, like it might have either bored you to death or you might have gotten one small thing out of this. But anyway, I think my job here is done if you remember just one thing out of this whole workshop.
Mhm.
But it was nice
Yeah,
being
for
here.
sure. All right, yes, thank you so much, Deep. Yeah, we will be seeing you tomorrow, and yeah, thank you so much.
All right. Thanks, guys.
All
Bye.
right, bye-bye. Okay.